Hi everyone, I am Arun JULKA. Today in Indefinite Integral Part 8, we will talk about integration of sine and cos functions. Integration of sine x respect to x is minus cos x plus c. Integration of cos x respect to x is sine x plus c. Integration of sine ax equals to minus cos ax upon a plus c, and the integration of cos ax respect to x is sine ax upon a plus c. First example, integration of sine x plus sine 2x plus cos x plus cos 5x respect to x. Integration of sine x is minus cos x. Integration of sine 2x is minus cos 2x upon 2. Integration of cos x is sine x, and the integration of cos 5x is sine 5x upon 5 plus c. Next point. Whenever we have sine square x replaced by 1 minus cos 2x upon 2, whenever we have quotient of cos square x replaced by 1 plus cos 2x upon 2. Next example, sine square x respect to x. Now when we integrate this, first we convert sine square x into 1 minus cos 2x upon 2. Take 1 by 2 common. Integration of 1 is x, and the integration of cos 2x is sine 2x upon 2 plus c. Next point. Whenever we have sine raised to power mx or cos raised to power mx, where m is even power. So here we talk about even power of sine and cos. First we say it is sine square x whole raised to power m by 2 or cos square x whole raised to power m by 2. Now replace sine square x by 1 minus cos 2x upon 2 and cos square x by 1 plus cos 2x upon 2. First we expand this and then solve. Next example, cos raised to power 4x dx. It is cos square x whole square. Replace cos square x by 1 plus cos 2x upon 2. When we expand this whole square, we will get 1 plus cos square 2x plus 2 cos 2x divided by 4. Take 4 outside, and now 1 as it is. Cos square 2x is again 1 plus cos 4x upon 2 plus 2 cos 2x. When we simplify this, we will get 1 by 4, 3 by 2 plus cos 4x upon 2 plus 2 cos 2x. When we integrate this, 1 by 4 outside, 3 by 2 as it is, integration 1 is x, 1 by 2 as it is, integration cos 4x is sine 4x upon 4, 2 as it is, integration of cos 2x is sine 2x upon 2, and after simplification we will get 1 by 4, 3x by 2 plus sine 4x upon 8 plus sine 2x plus c. Next point, whenever we have sin x whole raised to the power n or cos x whole raised to the power n, where n is odd. Here we talk about odd power of sin x and cos x. First, we separate one sin x or cos x. Then we convert the meaning into terms of square. If we have sin square x, we convert into 1 minus cos square x. If we have cos square x, we convert into 1 minus sin square x. Put cos x or sin x equals to t having even power. I will explain with the help of example. We have question sin raised to power 5x dx. So first we separate one sin x. So it is sin raised to power 4x into sin x. Now sin raised to power 4x is sin square x whole square. Now when we have sin square x, it is replaced by 1 minus cos square x. Now put cos x equals to t. Differentiate respect to x both sides, we will get minus sin x equals to dt by dx. So sin x dx is minus dt. So sin x dx replaced by minus dt and cos x replaced by t. And after expanding, we will get minus 1 plus t raised to power 4 minus 2t square. And after integrating, we will get minus t raised to power 5 by 5 plus 2t cube upon 3 plus c. And replace t by cos x, and the answer is minus cos x minus cos raised to power 5x upon 5 plus 2 by 3 cos cube x plus c. Next point, whenever we have sin raised to power nx into cos raised to power px or sin raised to power nx divided by cos raised to power px or cos raised to power nx into sin raised to power px or cos raised to power nx divided by sin raised to power px, where n is odd power and p is any value, either even or odd fraction. Break only small odd power in numerator and solve as we solve quotient of odd power. if we have quotient cos cube x into root sin x. So first break only odd power is just cos cube x as cos square x into root sin x into cos x. Now convert cos square x into 1 minus sin square x. Put sin x equals to t. Differentiate respect to x both sides and we will get cos x equals to dt by dx. So cos x equals to dt. Replace cos x by dt and sin x by t. And after expanding we will get root t minus t raised to the power 5 by 2 dt. And after integrating we will get t raised to the power 3 by 2 upon 3 by 2 minus t raised to the power 7 by 2 upon 7 by 2. Replace t by sin x and the answer is twice of 1 by 3 sin x raised to the power 3 by 2 minus 1 plus 7 sin x raised to the power 7 by 2 plus c. Next question. We have cos cube x into sin raised to the power 5x. Both powers are odd, but we'll break only small odd power. So we'll say it is cos square x into sin raised to the power 5x into cos x. So break only cos cube x. Now cos square x replaced by 1 minus sin square x. Put sin x equals to t. When we differentiate respect to x both sides, we have cos x equals to dt by dx. So cos x dx equals to dt. Replace cos x dx by dt and sin x by t, and after expanding t raised to the power 5 minus t raised to the power 7 dt, integration is t to the power 6 upon 6 minus t to the power 8 upon 8 plus c, and replace t by sin x and we'll get sin to the power 6x upon 6 minus sin raised to the power 8x upon 8 plus c. Next question. Sin cube x divided by cos square x. Here we break odd power in numerator. So it is sin square x into sin x divided by cos square x. Now sin square is 1 minus cos square x. Put cos x equals to t. When we differentiate respect to x both sides, we'll get minus sin x equals to dt by dx. So sin x dx equals to minus dt. Replace sin x dx by minus dt and cos x by t. And after simplifying and integrating, we'll get minus t raised to the power minus 1 upon minus 1 minus t plus c, and replace t by cos x, and after simplification we'll get sec x plus cos x plus c. Next point. Whenever we have dx divided by 1 plus minus sin x, rationalize it. And whenever we have 1 plus minus cos 2x in numerator or in denominator, or we have 1 plus minus cos 2x in root in numerator or in denominator, then replace 1 plus cos 2x by 2 cos square x and 1 minus cos 2x by 2 sin square x. We can explain with the help of example. First example, dx divided by 1 plus sin x. So whenever we have dx divided by 1 plus minus sin x, we will rationalize it. So after rationalizing, we will get 1 minus sin x dx divided by 1 minus sin square x, which is equals to cos square x. And when we separate both, we will get sec square x minus sec x tan x. And now when we integrate respect to x, we will get tan x minus sec x plus c. Next example. Integration of dx divided by 1 plus cos 2x. The 1 plus cos 2x equals to 2 cos square x. Take 2 outside, so we have 1 by 2. 1 by cos square x is sec square x, and the integration of sec square x is tan x plus c. So answer is 1 by 2 tan x plus c. Next example. Integration of in the root of 1 minus cos 2x. 1 minus cos 2x is 2 sin square x. When we simplify this, is this root 2 integration of sin x. And the integration of sin x is minus cos x. So answer is minus root 2 cos x. Next point. Whenever in a root we have 1 plus minus sin 2x, it is equals to cos x plus minus sin x. Next example. Integration of the root of 1 minus sin 2x. We can replace 1 by cos square x plus sin square x. And sin 2x is 2 sin x cos x. So this becomes cos x minus sin x whole square. So root is there. So after simplification we will get cos x minus sin x. And the integration of this is sin x plus cos x plus c. One more example, integration of in the root of 1 plus sine 5x. We can replace 1 by cos square 5x by 2 plus sine square 5x by 2 and sine 5x by 2 sine 5x by 2 plus into cos 5x by 2. This is the formula of cos 5x by 2 plus sine 5x by 2, and which equals to sine 5x by 2 whole divided by 5 by 2 minus cos 5x by 2 divided by 5 by 2 plus c. Next point. Whenever we have 2 sin A cos B, the formula is sin A plus B plus sin A minus B. Whenever we have 2 cos A sin B, the formula is sin A plus B minus sin A minus B. Whenever we have 2 cos A cos B, formula is cos A plus B plus cos A minus B. And the last one is very important. Whenever we have 2 sin A sin B, the formula is cos A minus B minus cos A plus B. So whenever we have question of trigonometry, we can use this formula. For example, we have sin 7x into sin 3x. First we multiply by 2 and divide by 2. So now we have formula of 2 sin A sin B. 2 sin A sin B is cos A minus B minus cos A plus B. So it is cos 7x minus 3x minus cos 7x plus 3x. After simplification, we will get 1 by 2 cos 4x minus cos 10x. And when we integrate respect to x both sides, we will get 1 by 2 sin 4x upon 4 minus sin 10x upon 10 plus c. One more example, sin 5x into cos 2x dx. Divide by 2 and multiply by 2. Now we have 2 sin A cos B. The formula of 2 sin A cos B is sin A plus B plus sin A minus B. So it is 1 by 2 sin 7x plus sin 3x, and the integration of this is minus cos 7x upon 7 minus cos 3x upon 3 whole multiplied by 1 by 2 plus c. Next example, integration of cos 3x into cos 2x into cos x respect to x. Whenever we have 3 functions, we take 2 functions, the bigger one and the smaller one. So we take cos 3x into cos x, divide by 2 and multiply by 2, and outside we have cos 2x. The formula of 2 cos A cos B is cos A plus B plus cos A minus B. So it is cos 4x plus cos 2x whole multiplied by cos 2x. After expanding, we will get half of cos 4x into cos 2x dx and half of cos square 2x. In the first part, we will divide by 2 and multiply by 2. In the second part, we will put the formula of cos square 2x, which is 1 plus cos 4x upon 2. Now in the first part, when we use the formula to cos A cos B, it is cos 6x plus cos 2x. And after simplification, we will get 1 by 4. Integration of cos 6x is sin 6x upon 6. Integration of cos 2x is sin 2x upon 2 plus 1 by 4 outside. Then integration of 1 is x and the integration of cos 4x is sin 4x upon 4. And when we take 1 by 4 common, we will get answer x plus sin 2x upon 2 plus sin 4x upon 4 plus sin 6x upon 6 plus c. Last example, integration of cos 2x minus cos 2 alpha divided by cos x minus cos alpha respect to x. Cos 2x equals to 2 cos square x minus 1. Similarly, cos 2 alpha is 2 cos square alpha minus 1 divided by cos x minus cos alpha. When we expand, we will get 2 cos square x minus 2 cos square alpha because 1 cancelled by 1. Now we'll take 2 common, and the formula of a square minus b square is a minus b into a plus b. So after simplification, we have cos x plus cos alpha respect to x. Integration of cos x is sin x, and the integration of cos alpha, because cos alpha is constant, so answer is x cos alpha plus c.